Picture yourself looking at the night sky. You see stars with various sizes and brightness. Do you think these randomly distributed stars could fall into groups? Our video contains answers for such questions. The main question we'll be answering in this lesson is how the HR diagram helps us to improve our understanding of the stars. The worksheet you received contains a standard HR diagram, closed and open questions, and some true and false questions that might refresh your memory from grade 9. Please answer the following true and false question before we start this lesson.
The Hirschsprung-Russell diagram is an important scatter graph of stars used in astrophysics. It marks a major step forward in stellar evolution, as astrophysicists have to study the stellar evolution with numerous stars and various stages in their evolution period to understand their change in property. The vertical axis of the HR diagram is the star's luminosities. It is given in units of the sun's luminosity. Since there is a wide range of luminosity, we keep the graph compressed by making the scale increasing by powers of 10. The horizontal axis of the diagram represents the sun's effective surface temperature and spectral type. Stars with higher temperature are to the left side of the diagram. Stars with lower temperature are to the right. On the HR diagram, the stars near the upper left are hot and luminous. The stars near the upper right are cold and luminous. The stars near the lower left are hot and dim, and the stars near the lower right are cold and dim. On the HR diagram, about 80 to 90% of the stars are located in the main sequence, running diagonally from the top left to bottom right of the diagram. The main sequence is where the hydrogen fusion is happening, which most stars do for most. Stars on the top left of the diagram have a higher fusion rate, which means that their lifetime is extremely short, about 10 million years. On the other side of the diagram, stars that are very small has a lower fusion rate. This means that they can last about 1 trillion years. That is longer than the age of our universe. The stars that are in the middle, like our sun, has a medium fusion rate, which is about 10 billion years. Some other trends on the HR diagram include the white dwarfs, which are on the bottom left of the diagram, very dim and have a relatively small radius, a bluish color that results in higher temperature. Giants and supergiants are located on the top right of the diagram. They are bright, huge, but with low temperature that makes them appear in red. The understanding of the HR diagram will help us to determine the evolution stage of stars, along with the property of the star. The luminosity is the total energy generated and released by a star. It is detected as the electromagnetic radiation released from a star in a second. According to Stephen Boltzmann's law, luminosity depends on the star's radius and surface temperature. It can be expressed where R is the star's radius, T is the temperature, and L is the luminosity. If we rearrange the formula, we will get the fourth power of temperature times the Stephan constant is equal to the energy release of the star divided by the area of the star. From this case, if we have two stars with the same surface temperature, one can be more luminous than the other, only if the star is larger in size.
For the stars on the main sequence, the relation of luminosity and temperature is dependent by the star's mass. This diagram demonstrates the greater the mass, the brighter and the hotter the star, the higher up it is on the HR diagram. In other words, it means the temperature, luminosity, and mass all increase and decrease together. It is expressed in a power relation, where m is the mass of the star and L is the luminosity of the star. The initial mass of the star decides which evolutionary stage the star will go through. These stages are determined by the amount of energy the star produces and its internal structure. Each evolutionary stage represents a change in luminosity and temperature of the star, showing the changing region on the HR diagram. A star like our sun revolves from a cloud of dust and gas in nebula. Cloud collapses under its own gravity and protostar forms. Temperature and pressure in the core of the cloud are sufficient to ignite hydrogen fusion in the core. The star stabilizes in the main sequence for billion years. Then the star enters the red giant stage. The star is now fusing helium to carbon, nitrogen, and oxygen. The core collapses after helium fusion finishes, which causes future heating and expansion of photons. Outer layers of the star are blown off during a shock wave, and the core condenses into a white dwarf, and no more fusion occurs. White dwarf gradually decreases in luminosity as it cools and remains in that position for a very long time. For a star with mass much greater than our Sun, the evolution path starts with a cloud of dust and gas that is mainly formed with hydrogen and some helium. Cloud collapses under its own gravity and protostar forms. The star is now stabilized on the main sequence. These stars is more massive than our Sun, and the fusion rate is much more shorter, which is about 10 million years. Hydrogen fusion cannot continue. The core collapses, which heats the photosphere, causing it to expand and cool. Then the star enters the red supergiant stage. Star is now fusing helium to carbon, nitrogen, and oxygen. What it can do, but a star like our Sun couldn't do, is that this type of star have enough mass to create fusion of elements passing nitrogen and oxygen up to iron, which have the most stabilized nucleus. The star is now at the most stabilized point. The star becomes a supernova, which is at the top of the diagram. The star cannot release any more energy by fusion. Catastrophic collapse of the core heated up to 1 trillion Kelvin. Exploded core of the star can either become a neutron star or a black hole if the mass is high enough.
The following closed and open questions are found on the worksheet with respected answer on the back. For the open questions, please carefully read the analyze and the hint we have given you. We hope this lesson will help you to improve your understanding of stars based on the HR diagram. Thank you for your cooperation, and this will conclude our lesson.